Finally, let's return to the question of mmap versus sbrk. Unless you're really replacing malloc and free in the C library, you should not be using sbrk because it doesn't cooperate with all the other functions in the standard C library that do use mmap. Many allocators are implemented with mmap then, so that they do cooperate. Um, the only problem with using mmap instead of sbrk is that our layout of blocks was depending on a contiguous sequence of blocks, right? We were using a number to represent both the block size and how far to jump to get to the next block in the list. With mmap, though, if you call mmap multiple times, you don't necessarily get contiguous chunks of memory in the way that sbrk promises. So what do you do in that situation? Well, you can use the sbrk-like strategy that we have on some group of pages that you allocate all at once. And then when you need more memory, you just allocate a new group and treat it like a whole separate sbrk-like allocator. And then you can just reserve a little bit at the front of your chunk of pages to form a linked list of pages. So that if you're searching for a free block, in the worst case, you would just go through all your pages looking for all the free blocks. Note that if you do this, then your page has some sort of header to do the chaining there, but then you can compute the address of your first BP from that page address. So you don't need a first BP or an array or linked list of first BPs necessarily. Another thing that can happen with mmap-based allocators is you might find that one of your pages, one of your chunks, has only an allocated block in it. Aside from the prologue and terminator, these should be zeros on the terminators. Aside from that, if your page is empty, then you could just unmap it using munmap and fix up your links so that you give memory back to the operating system. And that is better if your application needs a notion of sort of instantaneous utilization. If at any point, how much are you using the memory that you've accessed from the operating system? While we're treating each of these as separate allocation arenas for various purposes, it can work just fine to have a free list, say, that is threaded through all of the pages, because here we were basing them on pointers instead of numerical offsets. It all depends on your data structure, whether you need to make each of those data structures page specific or page chunk specific, or whether you can have it threaded through the whole set of pages.